I would like you guys to join me welcome Al Griffin for today's lecture from TI. Oh,
No, not that you wouldn't do a fantastic job introducing Al, but I wanted to steal the microphone. Really just to say, the world of semiconductors is enormous broad, and one of the most fun things I've had from my personal experience is quite how many rabbit holes it's taken me down as a scientist and engineer. And I'm really pleased to welcome our guest, Al Griffin, who's one of the TI only has 3 senior fellows. And he's going to share some of his insights from his career and experience. A word on Texas Instruments is also that they are one of the OG semiconductor companies. And not only did they arise right at the very beginning, before, well, chips were pretty much very, very novel integrated circuits were. They also have continually reinvented themselves and still stand as pretty much world leaders in a whole variety of different types of microchip designs. They're also one of the very successful IDM companies, which you've done, looking at the kind of pre-readings that you guys have done, where these days many companies operate in a fabless way, while TI has been extremely profitable, running its own fabs and building its own chips for many years. But again, I'd like to welcome Al, and as I say, his insights into the huge and multidisciplinary world of semiconductors, and also as proof of it doesn't kind of matter where you start as to where you end up, I guess is another way of putting it. So thank you very much, Al.
Thank you so much. It's really an honor to be here. Never in my wildest dreams did I ever think that I'd be invited to one of the top Midwestern schools or Northeastern schools. Me being a Texas guy, being from El Paso, Texas, I always have been giving lectures at UTEP or at Rice University or Texas A&M. So this is the first time I actually get to come here. And as I tell you a little bit about my story, I'm going to walk you through a little bit about the ties I had with Purdue way back when with some family members as well as another school. And when you get to the slides, where you're going to see one of these slides, you're going to, no disrespect, okay? I'm going to tell you up front, it's just one of the only pictures I have of me and my grandfather in one of the old jobs that we did. And I'll tell you a little bit about that, okay? So without further ado, I think the down is forward or up is forward. Thank you so much. Okay, so I'm going to tell you about my career. And I think it's a little bit important because I didn't end up where I thought I'd be in several different ways. But also I'm going to tell you about how cool it was to end up with TI. Because I actually admired TI. When I was a kid, one of the first things I ever had was one of the first TI calculators. How many of you actually know that TI makes calculators? Very cool, very cool. How many of you know that pretty much any electronic gadget you have has probably got a TI chip in it? Your phone, your car, your blender, and I'm going to tell you a little bit about that as well. So yes, I'm actually a senior fellow at TI. I've been at TI 30 years now. And believe it or not, even though I look real young, I've been doing this for 40 years. 40 years. What's the laugh for? Oh, it's my wife. Oh, my God. So I'm going to tell you a little bit about what I want you to take from this talk. I'm going to tell you a little bit about myself. Probably going to tell you a lot about myself. That's really what I focus on a lot because it's been the most helpful, I think, for students. I'll give you my background. The top 5 tips from my grandfather, who actually is, to this day, my biggest influence. And even after he passed away, I still talk about him all the time because, I kid you not, the 5 lessons I'm going to tell you about what he told me to do in my career have made my career, okay? I'm also going to tell you about my red team. The red team is a problem-solving organization. It's very material science focused. We work on the worst problems at TI. Customer returns, internal problems, even something as goofy as somebody changed the cardboard boxing that they ship our wafers in or chips in and they cause corrosion. If nobody knows anything about it, it comes to my department and we try to figure it out. Then I'm going to give you, hopefully if I get to it, I'm going to give you a worldwide materials related problem that the red team worked on. And I'm proud to say we were probably one of the first in the industry to figure it out. But for my sins, TI did not want to publish it because they felt we'd be giving too much information away. So we kept it as a trade secret. And I started to see everyone publishing little by little over the years. And I was like, man, that could have been me. I could have been somebody. And then I'm going to give you some closing remarks and hopefully a little bit of advice for you all as you embark on your education and ultimately your degrees and your careers. So the objectives, I'm going to give you a glimpse of my life, pretty much. I actually started off as a metallurgist, and my intent was to end up either working at Inland Steel here in Gary, Indiana, because I had a cousin that used to work there, who eventually became CEO there one time. And I also thought I'd end up maybe working in the copper smelters of West Texas. And why? Because I actually love metals and metallurgy. Even when I was a kid with my grandpa, when we'd go to the mountains in Rio Doso or the mountains of Chihuahua, we'd go looking for rocks, and I would just love finding pyrite or was it geodes. I'd cut them up. I still have a lot of those rocks to this day. My mom's actually saved them. But the one thing I also want to tell you is that my career, I think, has been crafted based on my reputation, okay, and how I treat people. I think that's been the one big difference, and also how I communicate has also been very, very important to where I've gotten in my career. And I also want to tell you, if you love what you're doing, you've probably heard this before, you'll never work a day in your life. And I don't feel like I work a day in my life. Well, my wife will probably disagree and say the last few months have been a little bit hard if you looked at what's happening in the semiconductor industry. But it really, really has been a joy to be in this environment because I really don't feel like I'm working. I'm having a good time. I actually apply my degree every single day at TI. Now, I'm also going to give you hopefully that practical material science problem. We'll talk a little bit about that later. So, personal information. I am actually a 7th generation West Texan. My family was in West Texas, came from actually Indiana. The Coopers from Indiana came actually down to West Texas, married into the culture, both Indian and Hispanic. And what you see here is me right there, my grandpa, my mom, my great-grandpa, and my great-great-aunt, Anastasia Cooper. I actually knew her. She lived to be about 110, one of the oldest living people in El Paso. And that house still exists to this day in West Texas. It's an old adobe home where my family was from. Okay. Now, this is the part where I don't want you to get upset, okay? I actually am Catholic, and I went to a school called Cathedral High School in West Texas. And it's founded by the LaSalle brothers, which are also up here in Chicago, and where there are also other cathedral high schools, Fighting Irish. So most of us are geared to go to Notre Dame, where I also had a lot of family. My cousin, who became CEO of Inland, used to play football for Notre Dame. Actually was in the Sugar Bowl, has his ring from 1976, which is my time frame as a little kid. And so I wanted to go to Notre Dame. I really did. And my grandpa and I did a lot of work in plumbing. He was a plumber and an electrician. Okay, not formally trained, but he really knew how to do all this stuff. And my love of materials actually started with him, with both the rocks that we look for, the minerals, and yes, the plumbing. Well, I'll be honest with you. I used to tell my grandpa, man, I don't know if I could do this for a career. What you see here, can you guys guess what all that stuff is all over us? Yeah, you said it perfect. I know you whispered it, which is great. He and I, well, more him than me, we were working on a house, and someone actually flushed the toilet, even though there was a sign saying, hey, workers underneath, and we both got covered in it. Now, underneath the house, this was one with a crawl space. You probably would have heard us just screaming expletives just like crazy. And when we came out, this house happened to be my grandmother's. My grandma took a snapshot of us, and I'm wearing the Notre Dame shirt. And that's why I realized, oh my gosh, Notre Dame, you guys have this long rivalry, right, with Notre Dame. Was it 88 games you guys have played over the years? You guys know your winning percentage? Nobody? Well, first of all, are you guys Purdue football fans? Raise your hand. That's it? Are you guys Notre Dame fans or what? Okay, so your winning percentage is around 30%. And well, you guys didn't know? The last 7 games, or 7 years, have all been won by Notre Dame. But as you saw, Notre Dame is starting 0-2. And you guys play them this Saturday, right? I might actually tell my wife, hey, why don't we go back to Purdue and watch the game? Because I'd love to see it. So long story short, I didn't mean any disrespect. This is the only picture I have with my grandpa, and I just happened to be wearing it. And I never thought I'd be giving a class at Purdue. You feel me? Okay. All right. So the top 5 tips that my grandfather gave me are: live by the golden rule. You all know what the golden rule is? Treat others the way you want to be treated. If there's one thing I think I'm known for at TI, is the way I treat people. Okay? Always look out for number one. It's something that he used to always tell me in Spanish, which is always look out for number one. And you know what that means? No one else is responsible for you and your career more than you. You can think that other people have an influence, and they do. They might have an influence, but what you do in your class when you're here, it's like playing golf. Nobody else influences your play. Only you are in charge of your own play. Okay? Always do your best no matter what you were doing. He always used to tell me that. When we were doing a lot of those jobs, and he would really enforce on me, you need to clean up everything for the folks at the house. And we would spend a lot of time cleaning, and I'd tell him, why do you want to clean so much? Just fix their problem and walk away. And he'd say, how am I going to get another job next time if I have that kind of reputation? Always do your best. Decide what you want to do, work hard to achieve it, and commit to it. Very simple. When I decided I wanted to be an engineer, he says, you got to commit to it, and you got to work hard at it. Lastly, he always said, if you don't like what you're doing, you can always decide to do something else. Nobody knew it better than him because his life was upended by World War II. He always had to adapt with no high school degree, but he always found a way to make a great living and actually find a way to teach a guy like me about metals and metallurgy with no degree. Okay? So now, metallurgical engineering, material science. I have my 2 universities here. I actually went to the University of Texas at El Paso, and these are the mountains of West Texas, and I lived not too far from here. And it was great to go there, but again, I was aspiring to go to Notre Dame, Purdue, A&M, anywhere but home. Unfortunately, I didn't do well enough to actually go anywhere other than UTEP. But actually, UTEP was a metallurgy school, so it ended up being pretty good for me. Then later, when I was working on my degree, again, I was a metallurgist because I wanted to end up in either working in steel or the copper industry. Unfortunately, around the time I got my first degree, the price of copper plummeted and they started to close down the steel mills up here. So the jobs for a metallurgist actually started to change. And so my grandpa told me, hey, why don't you go into this semiconductor business and work for IBM? And I told him, why IBM? And he used to say, he's looking at the Wall Street Journal and he says, IBM's the #1 company that never lays off. He says, you ought to go work there. And unfortunately, I had to take on a much longer road. I couldn't afford any college, so I ended up working at ASARCO, the American Smelting and Refining Corporation, which is across the street from where my mom lived. Okay, well, not across the street, maybe across the highway. It was very close. This is gone now, but you used to know that you were arriving in El Paso if you were driving from California or driving from East Texas. You go through El Paso. When you saw that tower, you knew you were home. Okay? And I worked as a laborer there to try to pay for school. I also worked at the ski shop in West Texas. Yeah, we had a ski shop because Ruidoso, New Mexico is only about a couple hours away. So I actually started to learn about materials other than metals. Learned about polymeric materials, laminations, plastics, binders, wood laminates. It really was very cool because it opened my eyes on what else I could do. And then once I actually got to Rice, I still had to work to make money because I didn't get a full scholarship to Rice, unfortunately. And when I got there, I had to make money the hard way. I got a job at Hughes Tool Company. A guy named Howard Hughes started that company. And if you ever have seen or heard stories about Howard Hughes, they're all true. If you've seen the movie with Leonardo DiCaprio, which is a great movie, you'll see that he was obsessed with cleanliness. And sure enough, everywhere where I worked, there was a sign in the restroom telling you, this is way back when, before COVID, exactly how and how long to wash your hands and at what temperature. A little tidbit of where I used to work. And then also, because I didn't get a scholarship to Rice, I applied for one through actually Notre Dame, which was one for minority students. So I actually got the money to go to Rice with a scholarship that was partially funded by Alcoa, which is also up here in Pennsylvania. So I came to work for Alcoa in the summers. And my professors from Rice said, well, why didn't you just work on your research? I said, I didn't have a scholarship. I need to pay for it. So after that, he found the money. And then all of a sudden, I didn't have to pay for anything. And I had a little extra money for a change. But that's how I got my master's degree. And I went to go work for the company that I wanted to work for, which is IBM. My grandpa actually was right. It was a great place to be. And the funny thing is, just little tidbits, because I love trying to teach you a little bit about history about semiconductors. That word think was above the entrance to every lab, every desk, every office at IBM. It was always everywhere, think. And the motto was that because he always wanted, Thomas J. Watson Sr. wanted the engineers to always be thinking. And that's one thing I took away from IBM, which was great. Always be thinking. But at around the time when I'd been with IBM for a few years, I asked them, hey, how do I become fellow? Because my goal was to become a fellow. And the fellows at IBM were very, very famous for being very, very sharp. The guy that found the solution to electromigration was actually a fellow from IBM. And I said, I want to do that. What do I have to do? You need to get a PhD. And you need to go up to the research group. So I decided to go get my PhD. But while I was there, around like 1984, this company called Apple was trying to challenge everyone. And they were creating the Macintosh for the very first time in 1984, which was very, very cool. So cool, I bought one. So cool, I brought the Mac to my job at IBM because I said, I can actually portable my work. And you know what the IBMers did? Because they got so mad. They cut my cable, the power cable. True story. I had to tell my grandma, you know that Apple computer you helped me buy, Grandma? They cut my cable. She goes, why? I took the computer to work. Why? It was to show them how portable it was, right? And she goes, why would you take it to IBM though? That's the competition. So anyway, this is the original logo, but Steve Jobs always had a thing against IBM, which is why all those old ads, and I know you guys are too young to know this, but all the ads advertising the Mac said, think differently. Yeah, think different. And it actually started to appeal to me, so much so I used to write to Steve Jobs, hey, I really want to work for Apple. I'm a material scientist. I think I can do something there. And I actually got one letter back and said, unfortunately, we don't build our own products, which back then in '84, they didn't. And we don't have a need for material scientists. We have a need for designers. Long story, though, I ended up actually getting offers from Apple to actually go there after I made fellow at TI. But anyway, during this time, when I was working there at IBM, in Austin, there was this big complex of IBM buildings. And across the street on Burnett Road in Austin was all the TI buildings. So when you go to lunch, you meet all these TIers and you talk about the technical careers and things like that. And I actually started to like the thought of Texas Instruments. And TI was founded in West Texas. And it was actually the International Geophysical Company, which made electronics for looking for what? Oil. Oil, exactly right. And so the original TI began as an electronics company to help people find oil. So these are our founders, Pat Haggerty. I forget some of who the other was. Oh, Jenkins, Haggerty, and two other guys. And Jack Kilby is the guy that actually invented the integrated circuit. He actually got the Nobel Prize, and he shared it with Robert Noyce from Intel. No, I'm sorry. I forget which company, but somewhere up in California. But when they got the Nobel Prize, they had to share it because they came up with the idea of the integrated circuit at the same time. So this was cool. And he used to have his office not far from mine. And he was a very, very tall man. He was about this tall. And one of my favorite things always walking by is having this Nobel laureate say, "Good morning, Al, how you doing?" Not the most cheeriest guy, but he was very, very nice and cordial to me in a certain way. But that circuit is really what's the foundation for the world around you to this day. I think this is called the chips or that changed the world type of class. TI is known as the company that changed the world because those integrated circuits allowed so many other things to be invented. On the left is the original drawing for the patent for the integrated circuit. And the reason I have a picture of the integrated circuit is if you ever visit TI, we actually have his office all decked out like it was way back when in the 50s. And it has the original circuit still there. It's cruddy, but that is what that does. A couple of resistors integrated with a transistor, all in one piece, which is now, of course, the heart of everything you see around you. And here, of course, maybe you guys recognize this. This is the TI calculator of today. Pretty awesome, graphing, things like that. This was the first one. My first one doesn't look much different than that one. It was just a few keys to do addition, subtraction, multiplication, and division. But that's where it all started. These are the innovations that we called that enable the world around us. That chips that change the world, you can thank Jack Kilby. So TI now does chips in everything. Industrial markets, automotive markets, personal electronics, communications equipment, and enterprise. Enterprise are the servers, the cloud. That is the biggest growing sector in the semiconductor industry right now. So much so that I've spent the last 2 years of the red team visiting every customer that we have that makes those servers to either help them fix a problem or help them improve the performance. And all of these areas are what's fueling all that growth that you see for TI. We're growing 4 new factories in Sherman. We just grew 2 in Richardson. We have 2 in Lehi, Utah. And of course, we have all the 6 there in Dallas, one of which is the one where I started. So the semiconductor is everywhere. I kid you not. If you guys have one of these fancy water bottles that tell you when to drink water, probably got a TI chip in it. Your mouse, your Mac, your phone, your headphones, your AirPods, whatever, our chip is everywhere. So I like this because it shows you the cars, the phones, the elevators, the lighting that you see in buildings, those self-driving cars, CAT scan equipment. I actually worked on one of the first GE ultrasound equipment, the chips to enable ultrasound imaging. Rockets, spaceships, blenders, your Peloton equipment, your health monitors, and planes. I mean, it's literally in everything. About the only thing you'll never see a chip in is now probably a mechanical watch. So now I'm going to tell you a little bit about my team and what we do. My team is the red team. And if you look at it, it actually, how many of you like comic books or manga? Hey, not too bad. Anybody recognize that drawing kind of style? Anybody? Anybody old enough to recognize that style? Well, that's the type of drawing, but who created that and for what comic book? You might have seen a lot of movies about it in the last few years. The Avengers, Captain America, Jack Kirby. Jack Kirby had this certain style with very white ink. So we created a logo because I like comic books, and I asked a friend of mine, can you make a drawing about making it very active? And what we did is we hid the TI bug in it and a wafer with a wafer notch in it. And the red team is just a problem-solving team. The reason we created it is because even I started off as a process engineer at TI. And I was telling Matthew earlier, I actually was rejected by TI 5 times, even though they paid for my degrees. The timing of me applying every time I got a degree, whether it was the master's or later the PhD, or when a friend of mine said, you should apply, every time I applied, there was a glut in the market. And I was turned down. And true story, I was invited to give a talk when I was at Los Alamos National Labs, and because I had to be a postdoc because I could not find a job, couldn't find a teaching job. There was an overabundance of PhDs in 1991. When I went to interview at A&M, there was 500 and some applicants. When I went to interview at Rice, there was 300 and some applicants. And at UT, I think there was 700 applicants to teach at UT Austin. And I'm in UT Austin, I think I made it to number 7 or 8 out of that number. And I didn't get picked because they considered me an applied engineer versus a theoretical engineer. But I came close. At A&M, same thing. We really don't have a materials program and we don't see how you can fit in, but you did very well. And we were wondering if you'd like to teach mechanical engineering. I thought, man, that's just a bit of a stretch for me because I'm always just materials oriented. So I actually got turned out so many times from TI because I couldn't seem to find anything. And so when I went and gave a talk, invited talk from Los Alamos, one of the benefactors from the TI Foundation that you saw was actually the one moderating the session. And he thought he'd make a joke. By the way, he was a senior fellow at TI. And he made a joke. Well, you know, Al here, he had a very heavy accent. Well, you know, Al here, we paid for his degrees, but he never came to work for us. So I went up there in front of everybody. He got a big laugh. And I go up there and I say, is now a good time to tell Joe I've been turned down 5 times by TI? And he turned red and I said, oh man, I made him mad. But after that talk, he said, I'm going to bring you back and we're going to hire you into TI. So he brought me back in 1996. Brought me back. I'm interviewing in the morning and it's going really well. And it looks like I'm going to be in R&D in TI. And I thought, man, it's perfect. It's the dream job. And back then, everyone had pagers, not cell phones. And when you got a page, we were at lunch. They all had to leave the table. I was with about 7 other people interviewing me. They all went to the payphone because you had to go to a payphone. You guys don't even know what a payphone is? You had to put a quarter in to try to make a call. They're all making calls, trying to answer, and they come back and say, hey, Al, all the recs have been closed. We've been told to tell you to just fly back home. They're like, wow. So when we got back to the office, I went to the lobby, had the admin call Joe and get him on the line. I say, hey, Joe, so you know, all the recs have closed. He goes, what? I said, yeah, I'm going to leave again, and this will be the 5th time or the 6th time that I'm going to walk out. And he goes, let me make some calls. I wait in the lobby for 2 hours, and he calls back, and he says, are you willing to interview in manufacturing? I have a PhD. I have 5 years experience in research and development in diamond films, buckyballs, Buckminster fullerenes, laser cutting of steel. I had all this experience and I was going to end up in manufacturing. And I said, Joe, I've been looking for a job for 5 years. You get me an interview, I'll go do them. So I interviewed that whole afternoon, I think starting at 2 or 3, went all the way till 7. And every interview that I had in this manufacturing floor for semiconductors, everyone said the same thing. You're too overqualified. The minute you get a chance to go and leave for, wow, that's fast. I told you I can babble. If you can actually stay here and take a job, it'd be great. But everyone thought you're going to go into R&D, the chance that the minute that things turn around, R&D is going to pick you up and you're going to go in there. And everyone told me the same thing. The last person to interview me, and I love to use her, Judy Shaw, she actually interviewed me and said, Cal, you look fantastic. But I'm so afraid that if I offer you this job, you'll leave R&D the minute that they open up a rec again. And I said, I'll make you a deal. You hire me and I'll work for you as long as we do this same job. I worked for her for 11 years. And I made this senior fellow in 8 years. I'm sorry, fellow in 8 years. And nobody thought you could do it in manufacturing, first of all. But the reason it worked out is because I was solving problems for TI, big ones. Even though I was a process engineer, I started to get loaned out to every factory. Hey, we have the line down situation, send out. Fine, it's great. But I wouldn't really get credit for it because I'm a process engineer. So in 2007, I approached our leaders and I said, what if we had a problem-solving team called the Red Team to try to solve problems? And they gave it to me. And I hired nothing but materials people and expertise in the weirdest things, memory, radiation hardness, material science. I'll be honest with you, 7 of the folks were all material scientists. And the reason, and people always ask, why do you keep on picking materials people? Because every problem, whether you work at TI or Inland Steel or Google or NVIDIA, I guarantee you the biggest problem is a materials integration problem. So one thing I told Matthew is like, one thing I want to make sure I give you advice on is get a good handle on your intro to materials. If you know materials, whether you're an electrical engineer, mechanical, industrial, doesn't matter. You will have so much power and you won't have to call in a team like the red team filled with material scientists to try to solve a problem. But that's what we do. We solve problems. And so they're just subject matter experts. There's always some, but this team was just focused on problem solving. And we're dedicated to determining what's called the root cause of a problem, meaning the true root cause, so you can fix it and you don't have this issue anymore. And we serve all critical needs across all of TI as well as quality. Now, technically I work for quality. And by the way, I did keep my promise to Judy, but when 2007 came around, the reason I left to go into quality is because there was a change in the direction. We weren't going to do R&D anymore. It was going to be sent to foundries. And so I wasn't going to be doing the same job. And when I went to go tell Judy, I'm going to go to quality, she says, you said you were going to stay with me as long as I hired you. I said, as long as we were doing the same thing. This is a time where we got to change. So I actually went to quality, and everyone said, quality is where careers go to die. In quality is where I made senior fellow. Why? Because solving problems is actually the biggest thing that you can do for any company that you work for. And the big thing that the red team does that's real different is we never focus on blame or responsibility. If you come into a room to help people, and the first thing you do is say, you messed this up or you did mess that up, it's not going to go very well. So the red team never focuses on blame. We focus on fixing the problem. And our charter, and this is real simple, to develop a fundamental and thorough understanding of quality and reliability problems across all technologies and propose a path to resolution, as well as ensure that we apply those lessons to all future products. We do that to this day. So the red team is almost going to hit 20 years of existence, and it's a small ragtag bunch of group of people with very different backgrounds. Now, the way we solve problems, and this is probably one good place to close if we don't get to do the technical problem, is we start by asking, what's the problem? The next thing that the red team does is, what data do you have about this problem? And we create a hypothesis for it. Once we have our hypothesis, we work on proving it. And the way the red team does it is, more than anything, we always try to replicate the problem, reproduce it. After we reproduce it, if we have a good handle on it, we now need to determine the risk, either the risk to TI or the risk to our customers. And then I ask, have we all analyzed the data that's available? And at the very end, have we solved or replicated the problem? Anybody recognize what this method is? What's that? The scientific method. It's known as the scientific method, though. It's very similar. And people always ask, God, you guys do such a great job. How do you do it? It must be magic. It's just the scientific method. Have a problem, propose a hypothesis, get the data to prove it, replicate it even better, and then prove that you can actually fix and eliminate the problem. Actually, that's what my team does. We will get rid of the problem. And if it doesn't work when you have a hypothesis, you start all over again. You ask yourself, what's the problem? So, I was told I think I was close to having time. So I actually have a technical problem that was the biggest problem that TI ever had. So if you want, I can maybe tell you how we fixed it. It affected everybody. Is that a yes, a yes? Does anybody have to walk out and run out? Okay, well, I'll stay as long as you want to ask questions if you want. But this is probably one of the coolest things I ever worked on. Why? Because it was actually copper corrosion. And where did I used to work? At a Sarco, at a copper smelter, where I take the stuff out of the ground, turn it into copper. Our problem was the copper was starting to go back to where it came from, copper oxide and copper sulfate. So the package chip and where it could go, I already told you it can go in all these places. How do we do it? If you don't know, the the chip goes inside a package. What a lot of folks don't know is the packages are actually epoxy, and they require chlorine to drive the epoxy hydrochloride reaction. So when you cure it, there's chlorine that has to do the magic. But if the chlorine stays there and it's mobile, it can cause corrosion. And just to give you an idea of where it's going to corrode, these are all the types of pictures of wires and wire bonds that TI makes to connect the chip to the real world. It goes to the leads in the package and the leads go to the PCB is in your computer. And unfortunately, people didn't realize that mold compounds, when they start to get humid, like in Singapore, we have a lot of problems in Singapore because it's always hot and humid. And the moisture goes into the package, releases the chlorine, and cause corrosion. So, another apology here. Why do you think we've used gold wire for so long? Unreactive. It's perfect, right? It's great metal. It's a noble precious metal, does not react with anything. It's stable at high temperatures, does not want to turn back into something else. Gold started off as gold. Copper started off as copper chloride, copper oxide, copper carbonate. Turquoise, if you like turquoise, that's all loaded with copper. And we found a way to take it out and turn it into copper. But Mother Nature doesn't like that and wants to turn it back to where it came from. So gold was the wire of choice for all integrated circuits until about 2009. So gold had a technical Achilles heel. Normally I ask you all, but since I'm in a rush for time, I'm going to answer it for you. The technical Achilles heel for gold is it's very expensive. And in 2009, the price of gold quintupled, and we lost all the profit margin on our chips because you saw all those wires. That was tons of gold wire that we were spending. And believe it or not, TI came to my team and said, hey, if we switch to copper wire, do you think it'll work? I said, well, it can work, and it actually lasts longer than gold because gold does not have gold has a very big problem of reacting with aluminum, and it reacts so quickly that it forms these voids. So gold aluminum joints don't last very long. So copper would work great, but unfortunately copper does have a problem. So this is the reason why we've used gold for so long. And believe it or not, I've always had the same slides that I've always shown since 2012. And it had the golden dome of Notre Dame as a reference to show everyone, this is why you choose gold. It's up there, about the worst thing that happens is birds poop all over it, okay? But because I was coming here, I said, I can't show the golden dome. So I picked the golden helmet of Purdue. You with me? See, this is why I wanted to stay longer. So gold is used because it doesn't corrode. The Statue of Liberty has a gold torch on it, and they don't have to do anything with it. Do you know what the color of the Statue of Liberty is when it was first delivered to us? It was copper colored, bronze, yeah, it was copper colored. But the minute it started to oxidize in air, it changed color. That's the problem with copper wire. So when they came to us, we told TI, hey, we need some time to study because the mold compounds have chlorine in it. Oh, no, it's going to be stable. We told them, you can't do this. And the price of gold was going up so high, the businesses couldn't take it. So they changed it. And when we started to get the reliability results, I have to change this for legal reasons. I can't tell you the device. I can't tell you the mold compounds, the die attaches that we use, but I can tell you that the copper wire was failing like crazy. 76 out of 77, 73 out of 77, 20 out, huge fail rate. Gold wire, no problem. And this is what I had told everyone, gold has no issue. You're gonna have to re-engineer all your plastics. But we kept moving forward. And right when we tried to start shipping, the customers complained. And we had to actually change it back to gold wire to give me time to work on how we're gonna fix this problem. So how do we figure it out? Super simple. We actually had a device in one of our old factories because we were changing the old factories right away. And we had this device that had all these bond pads that are aluminum lined up in a row. I chose that because we were being really pressured. You need to find the answer quick. So I noticed that on this device, they were biased alternatively. Ground, positive. ground, positive. So I said, in one cut, I can give you the answer. Believe it or not, we cut one device. Every pin number 1, which was sometimes passing, sometimes failing, and I had this strange dark line in there. The ground pin next to it, pin number 2, didn't have the dark line. Pin 3, dark line, positive voltage. You see a trend here? If you look really, really careful, there was a problem. We were getting opens because of corrosion at the interface, that little thin line. We showed you a slide earlier, not mine, during the class at the beginning, had a word in it. Anybody know what that is? Galvanic corrosion. When you have two dissimilar metals, aluminum and copper, the difference in electron densities and electron affinities set up a battery. And if there's any water and chlorine there, the battery drives, guess what? A corrosion reaction. Don't believe me? I actually started off as a transmission electron microscopist when I was at Rice. So the first thing I said is, let's TEM them, which is super thin slice that is electron transparent so you can see what's happening in that thin dark line. A dye that has no reliability test has no problem. Red is copper, blue is aluminum, and green is oxide. No problem. Everyone's where they need to be. The failing pin, the one that was always biased positively, I have now this magic green layer with red dots in it. It's basically aluminum oxide embedded with copper particles. And then I said, okay, let me go look at the passing part, or the one that's flaky. The flaky one, passing sometimes. And it had the same problem, meaning there's a little bit of connection left. This is when we told everyone, every pin that sees a positive bias in the presence of chlorine is going to fail. And that's what happened. So again, people didn't believe us. So what we did is this is that same picture I showed you. This is actual fail. There was that no reliability test. That's my reference. This one, me and my friends sprayed chlorine on purpose on the aluminum pad, bonded with the copper wire, didn't put any plastic on it, and just ran a test on it. And it formed the same thing that was on the actual fails. So I replicated the issue by spraying chlorine on it with a little airbrush tool. And that's how we stopped everyone from madly trying to change it and try to throttle it back and try to engineer the plastics. The model, by the way, super simple. I'm going to close with this. The mold compounds here represented in pink with all these silica filler particles in there. I have a copper wire to an aluminum bond with its bond here represented in pink and yellow. And I have all the chloride ions here. First thing to happen is a diffusion mechanism. When we actually run our bias humidity test, you're soaking the part in moisture. So as it soaks, it turns blue and it has water in it. But the magic happens when I have one pin that's biased positively versus one that's at ground or negative. So the one that's biased positively is going to attract the chloride ions, and they're going to move in, and you start to grow that oxide. And it basically moved from the outside in and continued until the point where we actually have separation and open. That was what I did probably in just a few weeks to prove it. But to change it and fix it took us 5 years because we had to change all of the formulations of all those plastics and all those packages. So the bottom line is we had this reaction between the intermetallic compound formed between copper and aluminum, Cu9Al4, plus oxygen from the water, plus the catalyst, chlorine, going to form aluminum oxide with copper metal. That's why I had copper nuggets in the middle of that aluminum oxide. So we basically proved the problem. We recommended changing the mold compound formulations to actually add ion trappers and or fix the issue and get rid of any random contamination of chlorine. And guess what? We were able to convert from gold to copper wire and save a bunch of money. So my advice is always have a quality mindset. Like my grandpa always said, clean up your room, clean up your work. Everything that you do has to have intention and dedication. But the main thing I want you to do is always do the right thing. No matter what company you work for, and I've worked for several, Sometimes you're going to be asked to do something that maybe is not that great, but you got to try to have the strength and the fortitude to do the right thing. That means be disciplined, be careful. A lot of my customers actually say that the red team, they love working with us because we're rigorous. You saw what we did for the copper wire problem. We do this for every problem that shows up. We're very customer oriented. I ask people to think, and I ask people to think TI-AI. You're going to hear that buzzword a lot, AI. To me, AI is actual intelligence. Always apply that every day. If you're waiting for a chat GPT or AI to fix your problem, you might as well go to computer science and not be an engineer. Why don't you let the computer scientists come up with all the AI? Doesn't mean that AI is not important. I'm just saying that you, in the role you pick, trust you and yourself and your thinking and your engineering skills. Okay? And by the way, have a zero defect mindset. I've had a problem trying to convince people that you have to have a zero defect mindset. I saw you guys are going to have an interview thing with Tesla. You know what Tesla's biggest thing is? They don't like to have a high PPM issue for their products. So you have to have a zero defect mindset, because can you imagine if you had a 2-cent chip that brings down a car? Not the thing you want to do. So, career advice that my dad gave me, which was also advice that David Glass, I guess, gave. I don't know if he got it from David Glass or my dad gave it to me, but every morning in Asia, in Africa, a gazelle wakes up and it knows that it must run faster than the fastest lion or it'll be killed. Y'all heard this before? Some yes, some no. Every morning a lion wakes up and it knows it must outrun the slowest gazelle or it'll starve to death. So the moral of the story is, it doesn't matter if you're a lion or a gazelle. Every morning when you wake up, and when the sun comes up, you'd better be running. You get me? So how I got here, I followed the golden rule, never said no to anyone. My wife knows this, I work too much. I always take on more regardless of where the request comes from. I don't care if you're a fellow or you're a technician. If somebody asks me for my help, I'll help. That's my brand, that's my reputation. Always help others, even if it means delaying my own work. That was me. I always give credit to those who did the work. I always try to spend my time listening, except today I'm obviously talking. And I became the go-to person and a master of what I did. That is the way you become senior fellow. That is when you become invaluable to somebody. That's my talk. Sorry I went on so long.
Okay.
I tend to do that.
Al. Well, for folks who have another class starting, if you guys wanted to quietly head out, that's absolutely okay. For the folks who have questions, if you're willing to stick around for a little bit longer, then feel free to ask it.
Yes, sir.
Okay.
It's my fault.
Just be loud.
Okay. So, first of all, it was awesome hearing you talk. It was really inspirational. So thank you for
thank
coming
you.
out today. If you had to boil everything down in the semiconductor industry so far into like one big question that the future generation of engineers should think differently about, what might that question be and why?
Okay, that's a great question. I think you should always trust your instincts and what you're doing to solve any problem. Really. The world around us is changing dramatically with all this AI and ChatGPT. As a matter of fact, a lot of people ask me, hey, why don't you just have ChatGPT create your slides? Because I was in a bind. I said, no way. I got to create it because it's my story, right? So again, in the semiconductor world, you're going to be challenged with a lot of automation in both the factories and also how we resolve issues and try to deal with returns and also new product development. But in the end, I still think people are valuable, and you should always, always trust your gut with that.
Thank you.
Okay. Yes,
Hi,
sir.
I loved your talk today.
Oh,
and
thank you.
I was just curious, since you work in a lot of problem solving, how do you approach a situation where you and your colleague have two different ideas on how to approach or solve a specific problem?
Okay, very important. The red team, what I always tell my team is be collaborative. Anytime we get a problem, normally if it's really bad, like we had one recently with one of the Korean customers, I actually will pull my team in together and ask everyone, hey, what do you think? What do you think? Always try to take the combined efforts of everyone to come up with the best solution. And a lot of people at TI will say, well, just ask Al and rely on him. I actually have a lot of people who work for me that also have great ideas. I have some 2 new hires that are really, really incredible. And a lot of folks say, well, no one listens to me because I have no title. And I said, when I had no title, people still listen to me. Why? Because I brought a certain type of trust and confidence and competence to what I did. And I said, if you just keep doing that, with or without a title, you're going to do fine. As a matter of fact, people say, are you ever worried that they're going to take your title away? Well, for financial reasons, yes. But for realistic reasons, I remember that when I started and I got this reputation, I had no title. When I came to TI, believe it or not, with a PhD, I had no technical title. I had to go through every rung step by step. So it was competence and confidence that actually made the difference. Okay.
As you mentioned before, TI is known for kind of being on the leading edge, like innovating the new big thing that changes the world in semiconductors. What do you think the next innovation like the IC is going to be, and how does TI aim to be the one who's doing that innovation?
Okay, great question. Do any of you know which is the one company that's growing the most? The one that I made a little bit of a joke about that's growing really quick? NVIDIA, AI. So NVIDIA, AI, servers, the cloud, they have one thing in common. They have these server boards that are in these rooms that are kept cold. They're kept cold because you're dumping a lot of power. One thing we've noticed is more customers have more problems as AI and ChatGPT use went up. So as the use went up, the power demand on the devices went up. So as the the demand on the devices went up, the problems went up because of self-heating and the heating generation within the circuits. So where TI has been working on is the integration of all these chips to actually have either good self-cooling or enough heat dissipation that you don't have to buy a fan that goes over it, or in one extreme, if you ever go look at some of the inventions of IBM back in the 80s, have these liquid nitrogen cooled pistons on the back of the chip to draw the heat away. So where everyone's going is to these demands for AI and server applications like in Amazon. Just imagine everyone in the world's buying online. Those are just making a lot of electron demands on the circuits. So the chips have to be redesigned to take the heat. And one thing that's really at the forefront is the multi-chip module. So now we have 3, 4, 5 die, all stacked inside one package. So imagine, it's hard to make one chip in one package. When you now have all these metal clips with solder trying to sink the heat or keep it cool, that's where the forefront of trying to meet these demands on these customers is. It's manage the heat and survive long enough. These parts have to last 10 years. And if there's one thing, how many of you know about electromigration? Current flow causes mass movement. As things get hotter and the lines get smaller, the current density goes high. And the electrons are pumping through at such a high rate that the momentum is being transferred from the electron to the atom. And as the electron punches the atoms move down the line. As they move down the line, we get a hillock over here and a void over here. Most of your NVIDIA or server applications that have that kind of heat are running into that problem. So the technology of the chip has to change to manage that current density and that heat generation. So it's all in the multi-chip module and what's called the power module. In fact, I think I had a picture of one of the power modules. And the other one is to have good heat dissipation in that package. That's your question? Okay.
I think we'll have to call it here. Right.
Oh,
I'm sorry, Al. If you're able to stick around for a bit afterwards, and
do you mind? If my wife doesn't mind, I'll stay as long as you guys want. All right. Oh, thank you.